My name is Madiha Mirza, and I'm currently working as a natural language processing engineer. I have been attending minibars since the last 8 years, since 2015, when I was back in grad school. But this is my first time presenting, so I'm very excited to be here. And I hope you all will gain valuable insights regarding generative AI from this session. So to give a little bit of background, I've been working with artificial intelligence projects since back in grad school and also on my work. And it has been my experience that artificial intelligence not just scales solutions, it also scales a lot of risk. And the consequences of this risk are huge. The artificial intelligence revolution has created the need of an ethical rule guiding the technology's development and usage. And due to its autonomy and capacity to learn, AI is increasingly inserting itself into people's lives and has started to influence our behavior. There has been continuous and vigorous debate around AI technologies and their transformative impact on societies. While mostly AI brings many advantages, it also underlines numerous ethical, legal, and economic concerns, primarily relating to human rights and social justice. Then there are concerns that AI might jeopardize human jobs, or that AI might fall into the hands of malicious actors, or directly or indirectly, AI might disseminate false information. And all this has negative consequences on the society. It increases prejudice, discrimination, so many other issues. So that's why it's important to view AI through the lens of ethics. There's a critical need of an ethical AI framework to build ethical, safe, and inclusive AI systems, as well as build remedies before irrevocable harm occurs. And most importantly of all, AI will have the greatest impact when everyone can access it and when it's built with everyone's benefit in mind. As the most famous saying goes, with great power comes great responsibility, and I think that holds very true when we're talking about artificial intelligence in general and generative AI in particular. And that is the theme of my presentation today. So the agenda and contents for today's presentation revolve around generative AI, what it is, the technological evolution that got us here. Then I will go into detail about large language models, which form the basis of ChatGPT. And then I'll also talk about what is unique about generative AI, which makes it a technology for everyone. And then I will also share ethical principles and considerations about this fascinating technology. I will talk about algorithmic bias, which is the reason AI systems generate incomplete or biased responses, and that can lead to inaccurate outcomes that infringe on people's fundamental rights. And then I will also share some real-world examples and also discuss some potential solutions to solve these ethical challenges. And then I will conclude the session with some takeaways, and I will also share some resources which the audience can consult to gain further knowledge about this very important topic. Now let's talk about why we all are here. It's because of ChatGPT, which has become the fastest growing web platform in the history and has set the record for the fastest growing user base, which is composed of all ages and from all walks of life. ChatGPT is called the iPhone moment of AI, and it reached 100 million users just 2 months after its launch. And that made it the fastest growing consumer application in the history. ChatGPT has woken up the world to the transformative potential of artificial intelligence, capturing global attention and sparking a wave of creativity rarely seen before. ChatGPT's ability to mimic human dialogue and decision-making has given us AI's first true inflection point. And what's fascinating is that everywhere, anywhere, can see this technology's true disruptive potential by using it themselves. At the foundation of ChatGPT are language models called large language models, which are the backbone of generative AI. I will go into detail about those large language models later, but first talk about the technology evolution that brought us to this point. Decades of human innovation have shaped artificial intelligence as we know it today, but there has never been a moment for AI like the current one. Let's reflect at the technology evolution, where we are today and where we are moving forward. In the early days of computing, mainframes dominated the landscape, and then as computing power became more affordable and widespread, we saw the client-server model emerge, which allowed businesses to distribute computing resources. The first decade of the 2000s marked the rapid advance of various machine learning techniques that could analyze massive amounts of online data to draw conclusions. And combined with the power of cloud computing, machine learning gives companies the tools for analyzing data patterns, finding insights, making predictions, and automating the task at a pace and a scale that was previously unimaginable. The 2010s produced advances in AI's perception capabilities in an advanced form of machine learning, which is called deep learning. Breakthroughs in deep learning enabled computer vision, which is the model that search engines and self-driving cars use to classify and detect objects. At the same time, natural language processing gave rise to voice recognition that allows AI speech assistants to respond to users in a natural way. Nowadays, AI is showing its power in different domains. In e-commerce, AI is being used to offer customers personalized shopping experience. Retailers are building recommendation systems by taking into account a user's history, their preferences, their interests, and by doing this, they're improving their brand loyalty and customer trust. Retailers are also providing customers the ability to do visual search, so customers can search anything without even typing a single word. In agriculture, AI is helping to improve the overall harvest quality and accuracy, known as precision agriculture. AI technology helps in detecting diseases in plants. It helps to identify pests, and it helps farmers identify deficiencies in soil. For example, AI sensors can detect and target weeds and then decide which herbicide should be applied to crops. AI for the automotive industry has improved user experience, enabling faster innovation cycles and enhancing the entire workflow in manufacturing and maintenance. Many of the safety features in today's modern vehicles use AI. One example is driver assistance systems, which can help alert drivers to possible dangers. And today, almost all new cars have sophisticated voice-enabled assistants that control the infotainment systems in the cars. AI in fintech is used for fraud detection, credit risk assessment, insurance, wealth management, and many other services. In manufacturing, AI has revolutionized supply chain optimization, predictive maintenance, and AI-powered robots have automated assembly line tasks. In healthcare, AI is helping doctors diagnose diseases like cancers and tumors quickly thanks to deep learning and neural networks. But unfortunately, AI is also being used for more frivolous and more terrifying things like creating deep fakes. Artificial intelligence has made it easy to fake photorealistic videos and images, and there is a lot of ongoing discussion about the ethical implications of deepfakes and their potential use for blackmail, intimidation, and inflicting psychological harm on individuals. Building on exponential increases in the size and capabilities of deep learning models, the years ahead will be about natural language mastery. The GPT-4 language model, developed by OpenAI, which has not been released yet, it marks the beginning of a new phase in the abilities of language-based AI applications. GPT 3.5, which is what ChatGPT is based on, is capable of producing human-like text, and GPT-4 is even better at understanding and producing various dialogues and responding to the emotions in the text. And models like this will have far-reaching consequences for all types of businesses, since language permeates everything we do. So now today we are in the midst of AI-first era, where AI, machine learning, deep learning, and natural language processing are amazingly transforming the way that we live and work. The best thing about this is that the access is being democratized, and in today's AI-first world, AI is embedded in homes and in every aspect of an organization, its people, and its processes. So what exactly is generative AI? Generative AI is the umbrella term for the groundbreaking form of creative artificial intelligence that can produce original content on demand. Rather than simply analyzing or classifying existing data, generative AI is able to create something entirely new, whether it is text, images, audio, video, speech, and even code. Generative AI learns from heaps and heaps of data. In fact, the GPT 3.5 model, which is the basis of what ChatGPT is, it was trained on over the entire public internet corpus, and that's why it is able to provide responses that sound so logical, grammatically correct, and it goes into full conversations about any possible topic. Currently, with Azure OpenAI, there are three main capabilities, which is what you see listed on the left-hand side of this slide. The first capability is based on natural language processing, which gives us ChatGPT models, which are good for summarizing text, answering questions, and Q&A scenarios. These models can answer about any question you throw at them. The second capability is generating code, and that is through the codex model, which you can use to translate code from one programming language to another. You can also use it to identify and troubleshoot bugs and also create new code. And the third capability is generating images, which is DALL-E. You can use it to generate stunning images for a particular purpose or just for fun. And all this happens just by giving descriptions in natural language text. When AI first started, it was mostly focused on two main tasks, classification and regression. Classification's goal was to predict a label, and in regression, the goal was to predict continuous values. As an example, for the pictures listed on this slide, the classification task was to make a decision about some variable x that is a multidimensional vector, where the vector has multiple entries. For example, a 1 megapixel image has 1 million pixels, with each pixel having 3 colors. That is 3 million dimensions. So back then, it was considered a pretty impressive task when models could accurately predict or classify an object to a category. But now generative AI models understand the distribution of a data. Once that distribution is modeled, the model is able to sample from it and generate new examples from the data distribution. So in order for a model to synthesize a new face, it needs samples from a distribution of faces, and that is accomplished through deep learning and artificial neural networks. The reason distributions are so important is because the data structure is captured in that distribution. Now, if you have a bunch of random images, almost 99% of that is just random noise with no structure. And it looks like it will be fuzzy like a static TV screen. And the number of images from the real world that contains some structure is very small. So the solution is to build strong and large models using deep learning and artificial neural networks to understand data structure and then generate new data from that data structure. That is incredibly powerful because we can construct distributions to be conditional on things we know that we want to use to influence the new content generation. We want to be able to control the output, so the output solves our problem. So now we feed a constructed distribution to our model. We describe the problem in the form of a condition to the distribution, and then we can sample from the results to get one of many possible solutions. And for this to be successful, the model has to be huge. These large language models are made up of billions to hundreds of billions of parameters, which are trained by going through millions of pages of material for a particular topic, while attempting to execute a specific task such as predicting the next word or the next sentence. GPT 3.5's deep learning neural network is a model with over 175 billion machine learning parameters. To put things into scale, the largest trained model before GPT 3.5 was Microsoft's Turing natural language generation model, which was trained over 10 billion parameters. These AI models not only absorb information on surface level, but they create internal representations that deeply understand the data structure and meaning behind the data points they're trained on. And that enables generative AI to create new content, whether it is an image or a text or a piece of code. The force behind generative AI models are language models, and these language models are at the core of ChatGPT's suite of models that are being developed by Azure AI, OpenAI. So language modeling is one of the oldest problems in natural language processing. A language model is a probability distribution over word sequences, and the goal is that given a sequence of words, compute the probability of the next word. So language models are very useful because all human activity is described by language. Discourse, semantics, syntactic, structure is all part of language. And language modeling is widely used in various natural language processing tasks. Speech recognition, which is what Siri and Alexa are, they were the first applications of language modeling for public adoption. And today, language models are used in many applications. They're the basis of virtual assistants, chatbots, automatic translation, spell checkers, text summarization, and automatic code generation. This is all made possible by language modeling. So there are two main ways to train language models. Traditionally, language models were trained using statistical techniques like n-grams. An n-gram language model uses conditional probability to predict the nth word based on n-1 previous words. The probabilities depend on the training corpus. An n-gram language model is context dependent. So in an n-gram model, the value of n can be extended to unigram, bigram, and trigram, and the power or the expressiveness of an n-gram language model increases with the value of n. So the higher the number of n-grams, the more accurate the prediction of the next word. But after the advent of deep learning, neural networks became an alternative to n-gram language models. In neural network language models, words are represented using an embedding vector. This allows neural language models to generalize to unseen data much better than n-gram language models. Word embeddings are a type of word representation that allows words with similar meanings to group together. The representation is a real valued vector that encodes the meanings of words in such a way that words closer in the vector space are expected to be similar in meaning. And each word is mapped to one vector, and the vector values are learned in a way that resembles a neural network. Neural language models powered by deep learning, they have advantages over probabilistic models because they do not need smoothing. They can handle much longer histories, and they can generalize over context of similar words. For training a set of a given size, a neural language model has much higher predictive accuracy than an n-gram language model. The first neural language models were based on word embeddings and recurrent neural networks, which are also known as RNNs. Then came LSTMs, encoder-decoder, and GRUs. The most recent advancement is the discovery of transformers, which has changed the field of language modeling drastically. Some of the most famous language models like BERT, ERNIE, GPT-2, GPT-3, and GPT-3.5, they're all based on transformers. So how do we measure the performance of a language model? If the language model is able to predict the next word accurately, we know that the language model is understanding the language correctly. However, the models do not operate directly on the words. They operate on tokens, which are subwords or a part of word. And the words are broken into tokens based on many different ways. Some of the ways are they can be broken on a character or a punctuation or any other token. So then the language model figures out which is the most viable token based on the machine learning algorithm we feed it. So the language models behind ChatGPT, they mark a significant turning point and milestone in artificial intelligence. So two things make large language models game-changing. First is that they have cracked the code on language complexity. Now, for the first time, machines can learn language, context, intent, and be independently generative and creative. The second, after being pre-trained on vast quantities of data, which is text, images, audio, these models can be adapted or fine-tuned for a wide range of tasks. This allows them to be reused or repurposed in many different ways. So what makes this generative AI technology unique? Generative AI has democratized artificial intelligence, and it has put AI into the hands of everyone. It has empowered the public with the benefits of this technology. Now, anyone, regardless of where they live or whether or not they have specialized or technical knowledge, they can partake in the wonders of this machine-generated wisdom. In the past, natural language processing, natural language interpretation and understanding was much less robust. Capabilities like question answering as well as summarizations and search were very limited. But with the advent of large language models, which are also called the generative AI models, training on massive amounts of data has significantly improved the natural language generation and understanding. So now the language models are being trained on the nuances and polysemy of language, which has made the interaction with the conversational AI much more natural and fluent. Before generative AI, there was limited personalization, but now with generative AI, it is so easy to provide personalized, engaging experience for end users. Prior to generative AI, it was difficult to generate new and creative responses to complex problems, but now anyone in any part of the world can generate text, images, and digital content however they want. Generative AI has become an essential creative partner for people, revealing new ways to reach and appeal to audiences and bringing unprecedented speed and innovation in areas like graphic design, media, and real-time personalization. Companies are turning to state-of-the-art artificial intelligence systems like DALL-E for their social media visual content generation. DALL-E creates realistic images and art based on text descriptions, and it can process up to 12 billion parameters when transforming words into a single picture. And additionally, programmers and software developers can use generative AI to boost productivity by rapidly converting one programming language to another, mastering programming tools and methods, automating code writing, and managing system documentation. This brings me to the most important part of this presentation: ethical considerations of generative AI. Besides the massive popularity of ChatGPT, potential risks of generative AI have been raised, especially around legal, ethical, and copyright issues. Given the tremendous scale that can be achieved with artificial intelligence, any ethical impact on individuals, society, and the environment can be greatly multiplied. I will discuss the 7 ethical principles and considerations as they relate to generative AI. The first is the issue of bias. Bias is a very important factor in machine learning and deep learning models. And generative AI models, like all machine and deep learning models, can be biased, inaccurate, and they can produce inappropriate responses. Since generative AI tools are trained on human-created data, there is risk that human bias can infiltrate the new content that's being generated. A major driver of bias in AI is the training data. AI takes on the biases of the data set it learns from. This means that if researchers train an algorithm on data that is skewed for race, gender, age, diversity, or any other category, the algorithm would learn that bias regarding that category. And there are many ways training data causes bias. The most significant one is personal bias. And that happens when the training data is taken from the various sources on the internet. We all have different perspectives and experiences. So knowingly or unknowingly, some internal biases can be projected in the data collection process when building machine learning models. ChatGPT itself is trained on 300 billion words. Large pre-trained models like ChatGPT, they're trained on mostly unfiltered internet data, and as a result, they can produce biased, unethical, and harmful content in their responses. Of course, the challenge with training the algorithms is that there's no such thing as a perfect data set. There will always be underrepresentation and overrepresentation in any sample. That is why mitigating bias in training data is a major key to developing ethical artificial intelligence. These concerns will remain valid until we have AI auditing agencies that can look into these models to ensure that they are not existing with any discrimination and prejudice. The second issue is inaccuracy. While the text generated by ChatGPT can delight the public with spontaneous and creative responses, these responses may not always produce accurate information. For example, when ChatGPT doesn't know the answer, it may fill in the blanks, which can potentially create false or misleading information. Another critical fact is that the data source of ChatGPT is time-boxed. So ChatGPT is only trained on data that has existed up to 2021. Then there's uncertainty around intellectual property, ownership of works produced by generative AI. One of the main challenges that ChatGPT presents to intellectual property laws is the issue of authorship and ownership. Because ChatGPT is essentially a tool that generates text based on inputs and algorithms, it is difficult to determine what or who should be credited as the author of the text it produces. If ChatGPT is used to generate a piece of writing that is later published or distributed, it is unclear whether the person who provided the prompt or the engineers who or the creators of ChatGPT model who should be credited as the author. Another challenge that ChatGPT presents is the issue of copyright infringement and plagiarism. Because ChatGPT is trained on a large data set of human-generated text, it is possible that the text may contain elements that are similar or identical to existing works. If that happens, the owners of the original works may be able to claim that ChatGPT is infringing on their copyright. However, it is unclear how the law would apply in this situation because ChatGPT is not a human and it cannot be held liable for its actions in the same way that a person would be. When you log into ChatGPT, there are a series of cautions and informational comments displayed. One of them is conversations may be reviewed by our AI trainers to improve our systems. This is to inform us that for all and any of the entered text prompts and the resulting output and all the conversation that we undertake with ChatGPT, it can be seen by their people. So sharing sensitive data and privacy protected information with ChatGPT is very risky. ChatGPT and similar large language models, they learn from the data we put in. And there are big risks in sharing sensitive business information with AI chatbots. There's some fear that if someone inputs sensitive company information in ChatGPT and asks ChatGPT to create a text around it, that information will forever become a part of ChatGPT training data, and anyone could gain information on that company simply by asking ChatGPT about it. The implications of generative AI, remembering and learning from user inputs, is far-reaching. The input that is submitted to ChatGPT becomes the training data for pattern matching and other computational intricacies of ChatGPT. So the prompts we provide to ChatGPT, they are forever a part of its training data collection. It doesn't mean that we should not use generative AI at all, but we should be extremely careful and mindful of how we use it. We should strictly follow the security and privacy standards and consider the risks and implications of sharing sensitive personal or corporate data in any prompts. Then another ethical concern for generative AI is that with large number of users, ChatGPT has the potential to cause misinformation at scale. So misinformation can flow into AI models as well as flow out of them. So generative AI can be misused to create convincing and realistic sounding social engineering attacks. And there are reports that scammers are using ChatGPT to generate sophisticated scam emails, phishing emails, and they're also producing programming code for malware. A positive thing is that ChatGPT uses a thumbs down procedure for incorrect answers. So the more people vote thumbs down on fake news, the better ChatGPT will get over time, and the new generative models will be able to combat the dissemination of misleading content. And then there are concerns about the environmental impact of training and deploying these generative AI models, because these large models are very, very compute intensive. ChatGPT is one of the largest language models in existence, with over 175 billion parameters, which means that the energy consumption of ChatGPT is substantial. It has been reported that the carbon footprint from training ChatGPT emitted 552 tons of carbon dioxide. The environmental impact of AI training not only needs copious amounts of electricity, but also tons of water to cool the data centers. Researchers have found that just in training GPT 3.5 alone, OpenAI consumed 185,000 gallons of water, which is equivalent to the amount of water needed to cool a nuclear reactor. The ethical implications of generative AI have significant implications for our future. Failure to address these ethical concerns could lead to a lack of trust in AI systems, limiting their potential use and adoption. Generative AI is still in its early stages, and there are growing pains as the global community is still trying to figure out how to manage the ethical challenges of this amazing technology's capabilities. Addressing these concerns require collaborative effort between developers, policymakers, and public. So we all have a responsibility to establish guidelines and regulations, help invest in research and development, and educate the users about the impact of generative AI. And the most important responsibility falls on the creators of generative AI. They should build responsible regulatory framework to ensure that AI is used responsibly. And as the end users, all of us can play a part by using such technologies in a responsible and ethical manner. By doing so, we can create a future where AI is used ethically and responsibly to benefit the society. This brings me to the end of the presentation. As I've mentioned earlier, all scientific progress carries risk. There are countless ethical considerations accompanying the development, use, and implementation of artificial intelligence in general, and generative AI in particular. If the technology is not designed to function ethically, it can expand historical discrimination, bias, copyright issues, breach of confidentiality, and misinformation. When designing or using AI, considering what should be done is as essential as considering what can be done. Placing developments in AI within a larger ethical framework provides a way to avoid bias, discrimination, misinformation, and build technology that benefits everyone. So to conclude, I'd like to reiterate that ethical considerations must be a critical component of any AI system. Technological innovation is the name of the game, and the winning formula is to innovate responsibly. On this slide, I've listed some resources which you can explore if you want to learn more about ethics in AI. There are lots of organizations and individuals who are doing great work to advocate for responsible AI. If you're interested in getting involved in this space, these are some of the resources to consult. And thank you everyone for attending my presentation, and let me know if anyone has any questions, comments, or would like to discuss anything regarding the ethical use of generative artificial intelligence. Thank you.